Greetings, math fans. All right, so today what we're going to do is some more complicated trig equations, solving trig equations. Everything was usually based on like sine of x and cosine of x. Now we're going to do something, and we're just going to start with an example here. If I give you sine of 2x is equal to root 2 over 2. What you guys need to realize is it's not that x is now between, x, here, I'm going to tell you this. X, of course, is between 0 and 2 pi, as always, right? But now we have a 2x. So here's the deal. This guy right here, this x, still has to be between 0 and 2 pi. But now it's 2x. Okay? So what we're going to do is we're going to multiply the whole thing by 2. And that tells us what that 2x has to be between. So the 2x has to be between 0 and 4 pi. So here's the deal. I want to make a little graph on the side here. Think about how we graphed this back in the day, right? When we set up a sine graph, you went, you did 2x, and that was between 0 and 2 pi, right? And then you divided everything by 2, and you got 0 less than or equal to x less than pi. Right? So do you guys agree this is one period? X is between 0 and pi. That's one period. And in one period, so if this is pi here, do you guys agree in one period, I would get two answers. Let's just say it was 1/2 and 1/2, right? I have two answers in one period. That makes sense. We've done that in the past. Well, now what's going on is I have between, it's in one, or in 2 pi I have 2 periods. So this is 2 pi here, and this is 1 pi. So here, what do you see from this, math fans? If this is 1 period in pi, and I've got 2 answers, that means in 2 periods, or up to 2 pi, I have 4 answers. So to kind of make a long story short, what that 2x does, the 2x doubles the number of answers. Okay? Same thing if I have a 3x there. If that was 3x, then it would be, in order to get to this point right here, you'd multiply everything by 3, and you'd actually get 3x between 0 and 6 pi. Okay? So 3x actually triples the number of answers. 4x quadruples. In other words, it just keeps going up by that magnitude. And what does 1/2 do? Well, we'll talk about that one in a little bit. Okay? But I just wanted to give you guys a general idea what this looks like. So let's go back and do this problem. Sine of 2x equals root 2 over 2. So here's the deal. You guys agree that the 2x, and the way I want to set up is you should really do this. X is between 0 and 2 pi. I want that to be a 2x because that's truly what this is right here. It's 2x. So I multiply everything by 2. So 0 less than or equal to 2x less than 4 pi. So that 2x now has to be between 0 and 4 pi, right? Because x is between 0 and 2 pi, 2x is between 0 and 4 pi. So here's the deal. I have 2x equals, and what are my answers? Well, this is from what we did yesterday, right? Don't you guys agree that it's positive here and here? So my reference angle, if we do it in terms, let's do this, obviously this is for pi. So our reference angle is pi over 4. So that means this guy here is pi over 4, and this guy here is 3 pi over 4. So 2x equals pi over 4, and 2x equals 3 pi over 4. Okay? Now, if you take a look at this guy right here again, 2x is between 0 and 4 pi. So do you guys agree that this is definitely between 0 and 4 pi? Well, what else can I do with this? I have additional answers. Well, what's an additional answer is by adding 2 pi to that, coterminal. So I can say 2x equals 9 pi over 4. And I can also do 2 pi to this guy. And so 2x is equal to 11 pi over 4. Are these values still between 0 and 4 pi? Yeah. 11 pi over 4 is definitely less than 4 pi. 4 pi is 16 pi over 4. Okay? So this is still valid, right? Do you guys agree? All this is valid because of this guy right here. 2x is between 0 and 4 pi, and it truly is. Well, now what I want to do is I want to solve each one of these guys. So I'm going to divide. I could divide each one by 2, or I can multiply by 1/2. I think it's easier to multiply by 1/2. So you get x equals pi over 8, x equals 3 pi over 8, x equals 9 pi over 8, and x equals 11 pi over 8. So go back to our original problem where x has to be between 0 and 2 pi. Are these values between 0 and 2 pi? They sure are. 11 pi over 8 is definitely less than 2 pi. So those are my answers, 4 answers. Okay? And again, it's double the number of answers. All right, let's try another problem here. It's really not difficult, but just remember, if it's sine or cosine, whatever, of 2x, double the number of answers. So if I do 2 cosine of 3x equals negative root 3. Okay, think about how many answers. Well, I know I'm going to have 6 answers. Well, I think so. Okay, as we talked about yesterday, if it's one of the quadrantals and it's equal to like 1 or negative 1, right? Then you only have, it's still the number, double or triple the answers, but you might have 2 answers and then 3 answers or 4 answers, right? Okay, I'm going to divide both sides by 2. So cosine of 3x equals negative root 3 over 2. Okay, at this point here, I want you guys to understand that 3x has to, first of all, x is between 0 and 2 pi. So what does 3x have to be between? Well, let's multiply it by 3. So 3x has to be between 0 and 6 pi. And this is really helpful only because it helps me to know when to stop, doing my number of answers. So here's the deal. Cosine is negative here and here. Okay? And the reference angle is pi over 6. So you guys agree one answer here is going to be 5 pi over 6, and this is going to be 7 pi over 6. So there it is. 3x equals 5 pi over 6, and 3x equals 7 pi over 6. Because think about it. Doesn't that make sense? It's 3x has to equal that. That has to equal 5 pi over 6, because what's cosine of 5 pi over 6? Negative root 3 over 2. Okay, so that's why it's 3x equals that, because this box right here has to be 5 pi over 6. So that means I need to figure out what x has to be. Obviously, when I solve it, I'm going to figure out what x is, and that'll be my answer. Anyway, I know that 3x has to be between 0 and 6 pi, so I've tripled the number of answers, so I'm going to add, again, plus 2 pi to that. So I get 3x, so I'm going to add 12 pi over 6. 3x equals 17 pi over 6. Okay, 3x equals 19 pi over 6. 3x equals, I add another 2 pi to those guys here, and that's going to give me 29 pi over 6. And 3x equals 31 pi over 6. Okay? And 31 pi over 6 is definitely less than 6 pi, because 6 pi is 36 pi over 6. If I would go, let's say I would get confused and I'd add another 2 pi to that, right? That would give me 41 pi over 6, which is bigger than 6 pi, bigger than 36 pi over 6. All right, so we got our 4 answers, and they're all between 0 and 6 pi, and now I want to multiply everything by 1/3, okay, to solve for x. So I get x is equal to 5 pi over 18. They're all over 18 now. 7 pi over 18, 17 pi over 18, 19 pi over 18, 29 pi over 18, and 31 pi over 18. Okay, and again, is that x between 0 and 2 pi? Sure is. 31 pi over 18 is less than 2 pi. Okay, and 5 pi over 18 is greater than 0, so we're good to go. And those are these guys right here are my answers. Okay, again, all between 0 and 2 pi. Okay, sounds good? All right, let's try one that is not necessarily quite as friendly. Square root of 2 cosine of 1/2 x minus 1 equals 0. All right, so we'll solve for it. We had 1. We get root 2 cosine of 1/2 x equals 1 divided by root 2. If I rationalize it, I get cosine of 1/2 x equals root 2 over 2. All right, that's cool. So potentially I have half the number of answers. Okay, well, it's cosine of square root of 2 over 2. Where is it? Well, first of all, what's my reference angle? Do you guys agree my reference angle is pi over 4? And do you guys agree that cosine is positive here and here? So if I'm cutting it in half, I'm going to get these answers here. Okay, because let's actually set up this inequality now. Do you guys agree we did this between 0 and 2 pi? So I want to get this to be 1/2 x. So I multiply the whole thing by 1/2. So I get 0 less than or equal to 1/2 x less than pi. All right, so now it has to be between 0, 1/2 x has to be between 0 and pi. So let's start that out here. 1/2 x equals, well, our first value, this guy is pi over 4, and this is 7 pi over 4, right? So 1/2 x equals pi over 4, and 1/2 x equals 7 pi over 4. Well, wait a second. Doesn't 1/2 x have to be between 0 and pi? That's not valid because that's greater than pi. So this is not an answer. That's why it's half the number of answers. It's the top part like that half. So this is my only answer here, math fans. So I multiply this by 2 to solve, and I get x equals pi over 2. And that's my answer. And that's still between 0 and 2 pi. Okay? If I would have gone further with this, I would have multiplied both sides by 2. I would have gotten x equals 7 pi over 2, which is like 3.5 pi, which is definitely not between 0 and 2 pi. So this is not an answer. My only answer is this guy right here. Okay? Let's try another one here. 2 sine of 1/2 x plus 1 equals 0. So we get, we're going to get 2 sine of 1/2 x equals negative 1, divide by 2, so sine of 1/2 x equals negative 1/2. Okay, what's the reference angle? Well, sine of what is 1/2? You guys agree it's going to be pi over 6, that's my reference angle. And sine is negative here and here, right? So it's half the number of answers. Okay, that's interesting. Well, let's set up our inequality. You guys agree x is between 0 and 2 pi. So let's get it to be 1/2. 0, 1/2 x less than pi. So 1/2 x is between 0 and pi. So what's my first answer here? If the reference angle is pi over 6, isn't it 7 pi over 6? So it's going to be 1/2 x equals 7 pi over 6. Well, wait a second. 1/2 x is between 0 and pi. And that's not. You can even see by the picture here, I'm going to get these are my answers, but I'm looking for everything that's negative. So that's impossible, right? You can't have any values. This is not a valid answer because it's not between 0 and pi. So the answer to this one is there's no solution. All right? This exact same problem, if it, let's say instead of a plus 1, it was a minus 1, and I got sine of 1/2 x is equal to 1/2, how many answers would I have for that? Well, wouldn't it be these two quadrants up here? So I would actually have 2 answers. So here's the deal. If it was like sine of 2x, I know I have double the number of answers. But if I have sine of 1/2 x, there's potential that it could be 2 answers, half the number of answers, or 1 answer. The first example I did with cosine, there was 1 answer. This example that I did with sine, there were no answers. When I did it with this sign right here being a minus, there were still 2 answers. Okay, so I think drawing this inequality actually helps a little bit because, so this guy right here that I drew, I think it helps especially when you have a fractional value. And the reason it helps is because then you can say, you look at it and you're like, okay, I set up my first inequality like this, and I'm like, oh, wait a second, that doesn't fit between 0 and pi, no solution. Okay, you kind of have an idea where to have your cutoff and the number of solutions. All right. All right, so let's try one more example here. And it's cosecant of theta minus cotangent of theta equals 1. brutal problem because it's not quite straightforward. So what we're going to do is, I'm going to write this in terms of sines and cosines. So it's 1 over sine of theta minus cosine of theta over sine of theta equals 1. So you guys agree it's 1 minus cosine of theta over sine of theta equals 1. So now you're allowed to cross multiply. I don't remember the last chapter you couldn't cross multiply because we're verifying identities. We're not verifying identities now, we're solving. So if I cross multiply, I get 1 minus cosine of theta equals sine of theta. Okay, it still looks complicated. So what we're going to do is, it's tough to deal with sines and cosines, but it's not so bad if I square both sides. Okay, because that's going to give me sine squares and cosine squares, which actually I can manipulate with my old identities. Sine squared plus cosine squared equals 1. All right, so if I square this, I get 1 minus 2 cosine theta plus cosine squared of theta equals sine squared of theta. All right, and then here's the deal. I don't want to mix all cosines and sines together, but I know what sine squared of theta is equal to 1 minus cosine squared of theta, right? So then I can say 1 minus 2 cosine of theta plus cosine squared of theta equals 1 minus cosine squared of theta. And what happens is the ones cancel when I subtract, and I wind up getting 2 cosine squared of theta minus 2 cosine of theta equals 0. Okay, let's keep going down here. And then now it's easy. Now it's a great factoring problem. I can factor out a 2 cosine of theta, and I get cosine theta minus 1 equals 0. So I get 2 cosine of theta equals 0, so cosine of theta equals 0, and I get cosine of theta minus 1 equals 0, or cosine of theta equals 1. Well, that's pretty easy, right? Cosine of theta, isn't this going to be two answers here? So pi over 2 and 3 pi over 2. And this one's going to be theta is equal to 0. Now here's the deal. As soon as I did this, math fans, let me highlight this. As soon as I squared the terms, you automatically introduce extraneous solutions. And this is why. Think about it. If I had x equals 4, okay, and I square, so it's just one answer, right? And I square both sides, I get x squared equals 16. If I take the square root of both sides, don't I get x equals plus or minus 4? I have just introduced an extra root, negative 4. So what you need to do is at the end, whenever you square it, you have to check for extraneous solutions. It's huge. Check for extraneous solutions. And then just what you do is you plug it back in the original problem. So original problem was cosecant of theta minus cotangent of theta equals 1. And so I'm going to plug in all these different values. I'm going to plug in pi over 2. So I plug in pi over 2. I get cosecant of pi over 2 minus cotangent of pi over 2 equals 1. Okay, cosecant of pi over 2 is 1. Cotangent is 0. Oh, that's good. I like that one. If I do 3 pi over 2, I'm going to get cosecant of 3 pi over 2 minus cotangent of 3 pi over 2. So that gives me negative 1 minus 0, which is negative 1. Boo! Nope, no good. And the last one is 0. Cosecant of 0 minus cotangent of 0 equals, well, what does it equal? It's supposed to equal 1, right? But what is cosecant of, these are both undefined. So this is no good either. So my only answer, math fans, is pi over 2. Now I got an easier way to do this one. Okay? And let me show you one of my students, 2011, Michael Serpek. He taught me on 11/9/11. He came up with an idea. He's like, Mr. Kerfus, he goes, this is an easier way. He said, once I get, look back at your notes, once I get 1 minus cosine of theta over sine of theta equals 1, he goes, isn't this just tangent of theta over 2? I'm like, oh yeah, it is. So tangent theta over 2 equals 1. So I can set this up as tangent or right, theta is between 0 and 2 pi. So if I multiply this by 1/2, I get 0 less than or equal to 1/2 theta less than pi. Well, how many answers do I have? Isn't tangent 1 here and here? And this is no good down here, right? Because it's not between 0 and pi. So I truly get theta over 2, or 1/2 theta, is equal to pi over 4, which is my answer right here, right? And then I multiply by 2, I get theta is equal to pi over 2. Okay? So that's it. Theta is equal to pi over 2. So this is like so easy. This is a great way. Michael came up with an awesome way versus like doing all of this stuff. But it is a good question because basically you see a lot of work here, but you see if you have extraneous solutions, if you square it ever, you have to check for extraneous solutions. All right? That's it, math fans. Have an outstanding day. Goodbye.